Hello and welcome. Today is day 14 of my 30-day cyber challenge. We are back on TryHackMe, and I am still currently working through the Introduction to Cybersecurity learning path. As you can see, we are in the module of Intro to Offensive Security, currently working out of the room of Web App Security. And today we are going to kick off with Task 3, Practical Examples of Web App Security. And as usual, I'm going to dive right in. So right off the bat, I can see that we're going to have a site that we're going to open up. So I'm just going to click it to see that we have it in the split screen. Awesome. And I'm going to minimize for now. We'll get back to that in a minute. All right. This task will investigate a vulnerable website that uses insecure DOR. So IDOR, which is insecure direct object references. IDOR falls under, I wonder if I could say that as EDOR. So EDOR falls under the category of broken access control. Broken access control means that an attacker can access info or perform actions not intended for them. Consider the case where a web server receives user-supplied input to retrieve objects, such as files, data, and documents, and that they are numbered sequentially. So let's say the user has permission to access a photo named image1003.jpg. We might guess that there are also image 1002 and 1004. However, the web app should not provide us the image even if we have figured out its naming convention. In general, an EDOR vulnerability can occur if too much trust has been placed on that input. In other words, the web app does not validate whether the user has permission to access the requested object. So just providing the correct URL for a user or a product does not necessarily mean the user should be able to access the URL. For instance, consider the product page of https store.tryhackme.thm product $ID = 52. We can expect the URL to provide details about product number 52, and the database items would be assigned numbers sequentially. The attacker would try other numbers such as 51, 53, 52, 54, and so on. This might reveal other retired or unreleased products if the web app is vulnerable. Okay, that all makes sense to me. Let's consider a more critical example. URL store tryhackme.thm customer user ID = 16. So again, we expect the users to have sequential IDs. The attacker would try another number and possibly access other user accounts. This vulnerability might work with sequential files. For instance, if the attacker sees 007.txt, the attacker might try other numbers such as 001, 006, 008. Similarly, if you were ID number 16 and ID 17, another user, by changing the ID to 17, you could see sensitive data that belongs to another user. Fair enough. Likewise, they can change the ID to 16 and see your sensitive data. Okay. So of course, we assume here that the system has a vulnerable EDOR or is vulnerable to EDOR. Click on the View Site button and let's see this in action. You will see a page showing an inventory management system. If you click on the Planned Shipments tab, you will discover that an attacker has managed to mix things up a bit. Notice how they send the wrong tires to each assembly line. For instance, they assign scooter tires and motorcycle tires to bike assembly. If left unfixed, all tires will go to the wrong assembly. We will hack the system back and undo the attacker's steps. On your activity, you can see the activity of one of the users. We have reason to believe that this website has an EDOR vulnerability. So we have a question today. Check the users to discover which user account was used to make malicious changes and revert them. After reverting changes, what is the flag that you received? So View site. All right, so we have instructions. This inventory management system manages all shipments related to tires. A competitor sent a group of malicious actors to sabotage our logistics. The attackers used the account of one of the employees and mixed up the planned shipments. So we need to correct it so production is not delayed. All right, so I'm just gonna kind of dive around here. Let's see what planned shipments we got going on. Bike assembly. We got winter scooter tires, sport motorcycle tires. At the scooter, we got bike tires and motorcycle, and at motorcycle, we got, oh, so we don't have anything going right now. So inventory management system, your ID is number 11. Okay. Name is Roddy, warehouse supervisor. Got it. Inventory, so we can see our SKU IDs here. Okay. Planned shipments we saw. And that's funny. Okay. So your activity. All right, let's take a look and see what we're gonna do. Check the other users to discover which user account was used to make the malicious changes. Okay, so we have 11. Let's assume, or not assume, but let's try 12. See what we get. New user. Let's try 10. Aha! So we got another warehouse supervisor. Do we do 09? Do we just do 9? Yes. Oh, it was you. You did it. It was the DBA. Revert, 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 revert. Ahaha. Edor explored. And there's our answer. Although, I want to click out. Can I click out? But it just goes back. It does. All right, cool. So let's hit submit. There we go. So we finished task 3, practical example of web app security, which means we are complete with day 14, and we are also complete with the web app security room. So that's it for today.